Hello, let's have some fun. So in this video, I'm going to be looking at finite state machines. Now, a finite state machine is a way of, well, it's a machine with a finite number of states, but it's a way of really formalizing the different behaviors that a system can have. So at the moment, we've got this map, and as part of making my game, I put in a debug mode where everything is viewed from the top down. And the way we can sort of switch between these is if I open up my app. I've got these lines here. So we've got the camera system has a regular update, but it also has like a debug mode update. And same thing with the render system. So if I run it right now, we will not see any of that. We'll just see the normal view. Just like that. But if I go back and I go back to my app and I replace these update statements with these debug updates, and I'll just not change the caption of the window, but anyway, then now this might be a little hard to see, but basically we've got a top-down view, and this is showing how the visibility culling algorithm is working. So what I would like to do is I would like to set it up so that I can quickly switch between these modes, and that behavior is not hard-coded, so my systems are not getting what's happening here. Anyway, my systems are not getting arbitrarily complicated, if that makes sense. And this is just a little toy example, but this is a pattern that you can apply to your program as you make it bigger and bigger. It scales a lot better. So what I'll do is I'll sort of open up a new file. I'll just call this system.py, and there are two things that I'm really interested in. I'm interested in a class to represent a state and a class to represent a system. Okay, now for the system, this system will have some useful code. For the state, it will mostly be placeholders because a general state is an interface, basically. So I want to define all the things that I can do with my state. So for my state, I'm going to update a state. I'm going to have code which runs when a state is entered into, and I'm going to have code that runs when a state is exited out of. Okay, cool. So as you can see, these are just placeholders. I've just got this here so that autocomplete will work, basically, but this is the interface for a state. Now, the meaning here with frame time is it just might be useful information to have. A lot of systems do take in frame time for their update info, and this integer that we're returning is the state that we're going to move into at the next time step. So states can report what should be changing in the game, which we're not going to use at the moment, but I've got this mechanism here just in case. And probably instead of 0, I should define these things to be nice. So I'll just go to constants, and then right down the bottom, I'll define 3 states. There we go. So most of the time, we'll have no change in state, but we also have these 2 other states that we can be in. Cool. So I'll just go back to my system and I'll import that and I'll return it as default. So we've got that. Now, as for the system is going to have 2 things. It's going to have a set of all states that we can be in, so all those states are ready to go. We can enter into them, exit out of them very quickly, and we're also going to keep track of which state we are currently in. Another thing I'm going to want to do with my my system is update my system. Okay, and the last thing I'm going to have for my system is the ability to change states. So we should be able to take in a new state and exit out of our current state and enter into that new state. Okay, there we have it. So by default, we've got none, which is what this if statement is checking for. It's just checking, that we are in a state that is valid and can be exited out of. And yeah, pretty much otherwise we update our state and then enter into that state. And that is the state which we'll have, there we go, update called on it. Just like that. Okay, so the rest of this video will be a little bit tedious, but basically it will be implementing all of this. So to start with, the three major systems which will be using this will be the world, the camera, and the render state. I guess the render system is the more complicated, so we'll start with that one. Okay, so to start with just our imports, I see getting everything from constants. All I'm going to import really is system, and this is a little bit laborious, but I'll just grab all of this code I said, and I'm just going to carve out the bits that I don't need, basically. So this part here, if I just compress this a little bit, so we're going to have three things. First up, we're going to have our render system. Then we're going to have our top-down state, which will inherit from our system. And then we'll have our perspective state, which again will inherit from our system. And then finally our render system. Did I say system? I meant state. Our render system will inherit. So what I'll be doing now is I'll be going through each of these classes and I'll be carving out the code so that the behavior is independently in those different classes. So to start with, top down, we do not need to reset OpenGL. That is done by the system sort of once upon creation. We also don't need to load textures. But what we can do is, because our system will load textures, we can take in those dictionaries and store them. There we go. So the way I like to, there are two ways that we can handle state. One way is to have our system and have our system store all of the state that we're going to need. And then upon creating, when I say state, I mean data, sorry. And then upon creating the actual state, we pass in a reference to the system that will own that. And then the state can go into the system and fetch any data that it needs. Another way is to have the state store and manage all the data that it needs explicitly. Now, although this leads to data duplication, it doesn't really lead to data duplication because these things they're references anyway. Under the hood, they're pointers. So we're not duplicating that much. But I'm going to go with that for the reason of data locality. It keeps the data closer to the functions that operate on it. So again, just carving out, set up OpenGL, we do not need that. Okay, setting up the models can get vastly simpler because I'm taking a top-down view. I'm actually going to use this floor polygon, basically, to represent everything, whether it's a wall or a floor or anything. So even though, again, there is some data duplication in the sense that this data will be in my perspective state as well, I'm going to do that. It's not a big deal. Texture coordinates we can keep. Normals we don't need because they're being used for backface culling, which we're not doing in debug mode. Wall colors we do not need because Again, debug view. Now, two things I note. First up, all these texture coordinates are the same, 0, 1, 2, 3. So you'll see that I'm actually going to simplify this quite a bit. It's not a big deal. It's not a big focus for this video, but it will get simpler. And then secondly, the wall textures and the floor textures and everything, the vertices, sorry, should all be the same. It's just this set of 4 things, which I know ahead of time. So I'm just going to get rid of all of this. Okay, so that's done. Reset transformation, yes, we're still going to need that. Apply transformation, yes. So see that I'm keeping the methods very local to the system. And this stuff we can get rid of, right? So loading textures, don't need it. So I go to this update debug, and because I'm now in the debug state, that is now my update function. Okay, so maybe not super exciting, but what I'm going to do now is I'm going to go into those draw functions and change them. So here I have draw wall, and then down here I have like draw wall debug, and I'm going to use the debug version. It's really not that exciting. I'm just paring down my Okay, so like I was saying, we are in a very restricted situation where we always know that these things are going to be 0, 1, 2, 3, which is the same as basically the point index variable. So instead of this extra indirection, I'm just going to use that variable directly. But otherwise, this is fine. Nothing needs to change. And then down here, the same for drawing the floor. Just get rid of that extra lookup. Okay, so that's top-down system done. Now I'll do the same for perspective. There we have it. Again, what do I say here? Pretty much we go through and we just care about these things here. We care about the drawing commands which have been recorded. We care about which faces have been culled from the wall blocks, the player position for backface culling. But yeah, that's it. So onwards. So I'm going to apply the same trick here because everywhere here where we have texture coordinates, they're always going 0, 1, 2, 3, which again, that's what our point index is doing anyway. So we can just get rid of that. And yeah, as you can see, we do have duplication on these methods. That's totally fine. Loading textures will not be handled here. I know that I'm repeating myself. That's just how it is. And now I can pretty much look through here and I can get rid of any debug functions. Okay, so we're almost done, but I guess the last thing I need to do here is, just like before, get rid of that extra indirection. Okay, so finally, render system. Okay, so not much needs to be added here. What I'll do is I'll just take my superclass, initialize it, and that'll basically set up the system-related variables. Then we can get rid of all of this stuff. But we do need to create our states. Okay, so looking through the rest of this, setting up OpenGL, yep, looks good. Setting up models, we do not need. All of this stuff we don't need. Just loading textures. And that's it. The update stuff is handled for us. That's handled by the system superclass. Good. So that is it. So what I'm going to do is I'm going to go back to my app and I'm going to set this up so that we're pretty much using, we just need to modify it a little bit. So I'll go to my app and then in my initializer, just under the creation of the systems, we'll have some state stuff. We start in debug mode and then I'll get my render system. And while I'm at it, I'll just import constants so that I can use those state constants. So I'll get my render system, change the state to, so we start off in first person perspective. And I'll go right down the bottom and I'll define a function which will be used to change the debug state of the app. Okay, this is a lot of fun. So then I'll go up to my key handling stuff and I'll put in an event for T key press, T for toggle, I guess. All right, let's see how this goes. Nice. Ah, how could I miss that? Okay. I was trying to pop a matrix that wasn't there. Let's give this a go now. Okay, so far so good. Now if I were to hit T, that's all right. We can fix that. All right, cool. I'm just ironing it out so our system passes that frame time along to the state for its update. Okay, fingers crossed. All right, so now we're in top-down view. Pretty much, that's our map in top-down view. Very interesting. Now, obviously the problem is that the camera is not updating for a top-down view. So I guess that's the next thing we'll do. Okay, so just the same as before, I will, duplicate everything. And again, the basic idea is these first two classes will be our states. And the last one will be our system. Cool, cool, cool. So the initializer is fine, and then the perspective, sorry, the update, yeah, it's fine. Okay, and then for the camera system, again, we don't need to worry about the update code. We just need to basically initialize this as a system and then go ahead and create the states. There we go. So all those states have been created. They are ready to go. We just need to tell this thing we just need to know how to use this thing. So we can go to our app, and then right down here in the state stuff, we'll go set the initial state for the camera system. In our update, we're also going to need to pass in the frame time. And then in our debug, we'll need to change that as well. Just like that. Cool. Okay, just checking through. Yep, I'm happy with that. I think. We'll find out. Okay, so here we are. If I hit T, everything is updated. So our camera has updated to a top-down view. The render state has updated to that flat drawing, basically. We can move around. Come on. And yeah, that's working. And you will note that there's this extra sort of debug info that I made, which is the cone of rays that I'm casting out. So I'm not going to go into super detail on how that was done. I'll sort of leave that as an exercise to the viewer, but all the info is there. As a matter of fact, if you look into the GitHub repo for this, you'll see a little bit extra that I added, setting up states for the world as well, but it didn't seem super critical, so I didn't include that in this video. But yeah, that's probably it for now. Sort of cool. This is pretty cool. And like I said, this is a toy example, but it does scale up pretty well for larger projects. Anyway, I hope you had fun sitting through my typing exercise, and I will see you again soon. Bye.